Alright, we're going to start off solving a relatively simple problem involving forces. So here we have an object, which we'll use this little square in the bottom left-hand corner. You know that its acceleration is 3 units to the west, so you know its acceleration is this way. And you know the mass of the object is 1 kilogram, and there's 3 forces acting on it. One of which you know is to the west, one of which you know is north, and the other one you have no idea what it is. Right, and so your goal is to find that third force. Now, there's a number of different ways to do this. However, there is a procedure for solving forces which works every time and is almost, hilariously robust. Whenever you're looking at a problem like this, what you should be asking yourself is, can I find the net force? And if so, what is it? Now, you can find the net force 2 different ways. Number one, you can find it using a mass and an acceleration, because the net force always is equal to what you see. Or alternatively, you can find it by adding all the forces together. And it's the relationship between these two methods that lets you solve every single one of these problems. So if you take a look at this, you got to ask yourself, well, do I have enough information to find the net force? Here, I have an acceleration, and I have a mass. Therefore, I can find the net force immediately. This should always be your first step. The net force can always be found by taking the mass and multiplying it by the acceleration that you see. Here our mass is 1 kilogram. Again, I'm going to omit the units just for simplicity. And we'll bold these properly because mass is a scalar. And as for the acceleration, you've been told exactly what it is. Now it's important here for you to write this as a vector. Because it is west, it's going to be negative, and it's entirely left, so it's going to be negative 3 in the x and 0 in the y. Right, because our acceleration is going straight to the west. Now, you can multiply this out very, very quickly. It's not particularly difficult to do. Our force, which will be in newtons, because we're working in base SI units, will be negative 3 in the x and 0 in the y. Right? That's step one. Always try to find the net force. Now, the question is, well, how do we find the third force? Well, at the end of the day, this net force, and the word net in general, literally means add. In other words, if you have 3 forces here, and you treat them properly as vectors, there's no real need to think here. All of the forces, they have to add up to the total, and the total has to be what you see. Those are the 2 principal takeaways from this particular lesson. Now, with this being said, we have the net force. I know it's negative 3 in the x and 0 in the y. This has to equal to the sum of all my other forces. Now, force number 1, I was told quite explicitly that it was 2 newtons west. So it'll be negative 2 in the x and 0 in the y. F2, we were told specifically, was 7 newtons upwards. So because it's straight upwards or north, it's 0 in the x and 7 in the y. And lastly, F3, we don't know what it is, but we're going to try to solve it. Now, this here can actually be solved very, very quickly algebraically. What you're going to do is you're going to bring the 2 forces associated with F3 over to the other side, or you're going to cancel them out from the right-hand side. If you do so, you can find F3 directly. If we take a look at the x-coordinates, we're going to be taking negative 3. We're going to be adding 2 to it, and then we're going to be adding 0 to it when we bring over these things from the other side. Likewise, in the y-coordinate, we have 0. We're going to be bringing 0 over. I guess we could use subtraction here. And then we're going to be bringing the 7 over by canceling it out with subtraction. So what you're going to get at the end of the day for your third force is in the x, you are going to have negative 1, and in the y, you are going to have negative 7. And you can check this. If you take F1, F2, and F3 and you add them all together, they must equal the net force every single time with no exceptions. And that is a fairly standard example of how one would solve a force problem.